There we go. Okay, welcome to the Ortus Developers Week. This is day 4, session number 2. Ortus Developers Week is a free week-long online conference. You can use our hashtag ODW2017. You can follow us on Twitter at Ortus Solutions as well. This is a conference led by the Ortus team and some community members. All sessions will be recorded and they can be found at ortusolutions.com/ODW, as well as the slides at slideshare.net/OrtusSolutions. Why ODW? Because we like to show and educate people and get the community involved with our developments and projects and all the new stuff. We like to expose our products, roadmaps, partners. And this is a week that is designed for developers, so take advantage of these great speakers that we have. Ortus Solutions, we are professional open source. We offer training, support and mentoring plans, architecture and design sessions, web development, and even mariachi singing. And we are an open source, so if you want to help us, you can become an Ortus patron. You can visit our website, patreon.com/OrtusSolutions, and you can help us how to keep our documentation and downloads online. That way we can maintain our Forgebox.io as well, as little as $10 a month. So this is our schedule. We are in the session 2 of November 9th. 2 announcements. We're getting closer to the CF Summit RESTful Services Bootcamp that is going on in Las Vegas on November 14 and 15. It's gonna be in the Mirage Hotel. It's gonna be a nice suite, so you still have time to get your tickets. That's the link right there in the screen. And there is a discount code that you can use to get a better price. ODW2017. Next year, we also have the yearly Into the Box conference. It's gonna be in Houston, Texas. So if you're a speaker or you wanna attend to the conference, go to the Into the Box website and be part of this great conference. So I'm gonna let Roland start sharing his screen, and I hope you guys enjoying his presentation. Go ahead, Roland.
Thank you very much. Can you all hear me?
Yes, we can hear you.
Okay, can you see my screen?
Yes, we can. It says Intelligent SQL Optimization.
All right, thank you. Hi, everyone. Good to be here. What I'd like to do for this next session is present to you Intelligent SQL Optimization by Pinedale Data. Our mission, Pinedale Data, we're based here in California, is to accelerate data for the back end, all data for the back end. The executive summary for this presentation is for anyone with a SQL database that wants to improve performance and cost. What we do is we quickly implement a data access layer for you. For you app developers, whenever you interface to a database, you always have to create some type of data access layer or interface to your data source. We are an off-the-shelf data access layer, so you don't have to do that. Pinedale Data is a data access layer that optimizes SQL. In other words, improves the performance of SQL without code changes. Another way of putting it is Pinedale Data is a database proxy that transparently auto-caches, auto-invalidates, so you don't have to figure out which queries to cache, what to invalidate. We automate the whole process. We also perform read-write splits so that as you scale out horizontally your data tier, instead of rewriting your code, of directing read queries to read servers and write queries to write servers, we can automatically do that through a simple policy on Heimdall Data, as opposed to you having to code that in your application every time. We also support automated database failover. So when a database, for example, replica, is deemed unhealthy or goes down, we can automatically fail over to the redundant read replica. This could be for planned outages for maintenance upgrades or unplanned outages as well. So we can ensure that there's business continuity. There is no downtime for the application, and especially for your end user. It would be transparent on a DB failover. On the average, Heimdall Data's data access layer with our caching can give 5 times improved performance, at the same time give 5 times increased scale with your existing SQL infrastructure. Again, there's no changes to your existing application or database infrastructure. We're a simple add-on. So if you have one app server and you put in Heimdall Data, we can give you the power of 5 database servers in terms of scale with our caching. And then lastly, not only performance, increased scale, but if you have a commercial database, we can remove or reduce your database costs, hardware and software costs, up to 50%, depending on the application. So you get 3 benefits by the way we perform SQL caching in our solution. Now, how are we unique in the industry? Because you've probably heard about SQL caching, SQL optimization for many, many years, if not decades. Well, first of all, when you deploy Heimdall Data, it requires 0 changes to your existing application or database. So we're not ripping and replacing. It doesn't require any code changes, and it doesn't require any database changes. We're transparent. Number 2, when we do optimizations, although it's optimizing SQL, it's not only for the database, but we're optimizing for the application as well. We're making the application faster. And we're doing that by client-side caching. And in this slide, it explains what the true benefit is. You would insert a Heimdall Data database proxy in between the application and your vendor database API. And when SQL goes to the database, we will intercept the SQL queries and cache the SQL results in L1, L2 fashion. We will cache it in the application server RAM, which is configurable, the RAM size, and then cache it on an L2 perspective to the grid cache of your choice. That could be Redis, that could be Hazelcast, that could be Amazon Elasticache, whatever you want. So when you're caching on the application side, what it's primarily removing is the network latency between the application and database. It's often neglected that there is network latency which causes application slowness, especially in a cloud environment, whether it be in Azure or AWS. So this is a distributed way of SQL optimization. Each application server will have a Heimdall Data proxy, and it's all being managed by a central console. Caching is automated, synchronization is automated across application server cache nodes, and invalidations are also taken care of as well. Again, how does it work? The Heimdall proxy intercepts and forwards the SQL traffic between the application database. Heimdall caches the SQL results only if it gives a performance benefit. So we just don't blindly cache. We're going to cache if it provides a performance benefit. And then Heimdall ensures that there's data consistency across the application cache nodes and that there isn't any stale data. How do we do that? Well, we use real-time analysis and statistics. We figure out what the query frequency and variability is, and then we figure out the relative performance of the cache versus going straight to the database. If it's faster going straight to the database to get the results, then it isn't worth caching. So what we provide is auto-caching only if there's a performance benefit, and if you don't want us to auto-cache everything, we provide cache recommendations on what you should cache and the benefits that you get. Here's an overall deployment diagram of how Heimdall data works, and it's rather simple. There's two blue components. The data access layer is where all the execution of the caching and all the feature sets that we do. So if you have 3 application servers, then you have 3 Heimdall data access layers. What it'll do is it'll do the auto caching, auto synchronization, and auto invalidation. So it has a caching solution as well as an automated DB failover. What's nice here is that Heimdall data is database vendor neutral for SQL. You can use Amazon RDS. You could use this in Azure. You could use SQL Server, MySQL, Postgres. It doesn't matter. We're database vendor neutral. And all of these access layers or database proxies, if you will be centrally managed by Central Console, which is a separate VM instance. Oh, we also support Oracle as well. I failed to mention that. You could also deploy us in centralized mode, if you'd like. Instead of deploying us in a distributed mode, which is the most scalable, the most performant, you might want to just use this as a central box for which all the application servers talk to, and then it will do the caching and the high availability. The benefits here is cost, obviously. You just have one instance. But in exchange, you have an extra hop in latency, and the performance isn't as great as a distributed approach. So you could use this, deploy this in a distributed fashion that's installed on each application server, or you could just deploy us as a centralized fashion, whereby all the app servers will talk to a centralized Heimdall data, which will represent on the behalf of your databases on the back end. There are 2 software packages that you can deploy us. Again, I mentioned that deploying Heimdall data requires 0 application changes. And the reason why is the first one on the left, we act as a JDBC driver. So if you're a JVM, it's very simple. We're a jar file that you're installed, and it sits between the application and your current vendor database driver. So if you're using MySQL, for example, all you do, and you're a Java app, a JVM, you would just not replace anything, but just insert a jar file in. And it's transparent to the application. It's a 5-minute installation, and you're done. But what if you're not a JVM application? Well, what we do is we have Postgres, SQL Server, and MySQL database proxy. And this sits also in your application server, and it runs as a separate process. And this will accommodate any programming language as long as you have a Postgres, MySQL, and SQL Server backend. So whether it be Ruby, Scala, PHP, Go, whatever programming language, even Java, as long as the backend is Postgres, MySQL, or SQL Server, we're going to work. We're going to add the benefits of caching, database failover, and a host of other features as well. Right now, I'm going to get into some use cases and provide some reasons why and how Heimdall data provides a benefit. The first one is a case study. Movie Times is a global ticketing website with over 1 million users, and they're deployed in AWS. Their challenge was that there was a surge in traffic that overloaded their database, and it was too costly for them to develop a caching solution. So they chose Heimdall Data because we could diagnose and cure their SQL bottleneck. And just with one click, we provided auto-caching into their Elasticache for Redis. The benefits was that we gave them 10 times increase in database scalability. We saved 2 developer resources, and they installed us in 1 day as opposed to having to develop this in 365 days. So it was a huge benefit in terms of cost, the cost of deployment, 1 day versus 365 days of installation, and it was a great win for us. The first use case is a hybrid cloud. If you have a situation whereby your database is on-premise, but you want to deploy your application in the cloud, there could be a tremendous amount of latency between the application and the database. Because Heimdall Data is caching not on the database side, but on the application side, client-side SQL caching, a lot of the queries that would have gone to the database, we are caching and serving out the results on the application side. So we're removing that network latency. And so the performance goes up greatly. So this is great for a hybrid cloud scenario. The second use case is horizontal scale out. Whenever you want to increase horizontally your write servers, your read servers, you no longer have to rewrite your code to accommodate this query goes to this read server or this write query goes to this write server. Now you can automatically do that by just including a policy in the Heimdall Data console saying, well, whenever you see a read server, you should go to the read replicas. When you see a write, you should go to the write server. So it's a simple policy. It's very easy to scale out the database without code changes now. Now I'm going to show you our console before I get into the demo. This is the analytics, which provides a tremendous benefit to the application user and the developer on your queries and where the bottlenecks could be. In this situation here, when you're running the SQL queries through the Heimdall Data base proxy or the data access layer, either one of those terms, what's going to happen is we are going to provide recommendations for you on what you should cache. So right here in this screenshot, it shows the first 11 queries that you should cache. And all you have to do is really click the button, and it will any cache query that you want cache, and it's going to cache. We have an auto caching button which will cache everything that we think that you should cache. We'll do a cache all, or you can do it selectively. And in this example, the first query, it says that it represents 13% of the overall database time. The duplicate query response is 100%. So in other words, it doesn't change very much. And the query response time is 700 microseconds just for that single query. Now watch when we cache it. When we cache these 3 queries, the top 3, it went from 700 microseconds to 70 microseconds. That was a performance improvement of 10 times just for those, just for that single query. So you can see the effect and the benefit of client-side based SQL caching. It was just a click of a button and they started caching all, and you got a 10 times improvement just on that single query, just due to the network latency. Not only can we do caching, but there's a few other features that I want to share with you that may be of interest to you. We do asynchronous execution. So if there are certain commands that you want to, that are being pulled through to the database, like logging, that isn't time sensitive, we can put that logging on a different thread and tell the application, yep, it's done, we're taking care of it, so that the application can continue on in its process. And then on a separate thread, the database will take care of that non-time sensitive execution, like for example, logging. What that does is it makes the application faster. And it's called asynchronous execution. The other piece that we can do is forwarding. we could forward or route queries to different databases, different data sources, like NoSQL databases, for example, and it could be routed to different regions, for example. There's a use case by which the application data needs to stay in the same region for which it was requested. So we can do that through the forwarding or the query routing feature. And then lastly, there's a query transformation. So we give analytics of the slowest performing queries. So instead of changing it in the application that may take time, there could be a quick patch whereby we show you the slowest performing queries. And if you know what that query should be changed to make it more efficient, you can say that slow query equals that new query. And so whenever we see that query, we'll transform it to the efficient query. So it's called query transformation. And hopefully that will speed up performance as well. Lastly, I'm going to show you a demo. I'm going to stop right here as I set up. Are there any questions that anyone may have on our on the Pinedale Data solution? Brad, you're going to have to tell me if there are.
No one's typed anything in the chat yet, so you're good.
Okay. Okay, right now, if there aren't any questions, I'm going to give a demo. This is an Odoo app, and I'm at the shopping cart now. And what I'm doing is I'm just shopping for some speakers, for a smartphone, and for some earpads, some accessories. And what you're going to see on the bottom screen here on the right-hand side is the cache hit rate, and how this application with Heimdall is improving performance. And I'm going to stop here, pause it. And if you see here with this application, I am getting close to a 90% cache hit rate, which is very, very nice. What it's doing here is that it's caching on the application side 90% of the queries that would have gone to the database. That means only 10% of the queries are going to the database. So it's a tremendous amount of offload. So you're increasing scale, you're increasing performance, and you're reducing database resources, which eventually you're reducing database costs. Okay? And so what I'm going to do here is, so at a 90% cache hit rate, that's huge. And so what I'm going to do here is do some analytics and show you a little bit about how we're optimizing it. So I did some, I clicked on the Analyze button, and what it's doing is it's doing automatic caching of all the queries. And we see the server time, the cache hit time, the query response time. And I'm just going to choose one query that may be really slow. Here's one right here. This is a select product ID, and it's taking 3 milliseconds. Okay, round trip time from the application server to the database. Now, when we're caching it, we're going to basically remove that processing time. And what I'm going to do here is on a separate GUI, log into, basically get the analytics from the database, strictly from the database side. I'm going to do a search on that. And what you see here on this query is that it's 22 microseconds. So let's do a comparison here. This is the processing time of the database, which is relatively good at 22 microseconds. But the complete round trip time is 3 milliseconds. So what does that tell you? First of all, with Heimdall Data's analytics, we see the complete transaction of from the application, the SQL query going to the from the application to the database, and the results coming back. And that's 3 milliseconds. And we've just found out what the database is telling us is that it's only 22 microseconds. So the processing time of the database is pretty good. What that tells us is what we can deduce is that it's a network latency issue. And that's the piece that's causing the application slowness. And we're eliminating that because we're caching it on the application side, and the queries don't have to go to the database and come back. And that's the benefit with Heimdall data caching. It's automated. It doesn't require any code changes, and you get some really nice analytics on what's going on with your SQL queries. Lastly, I'm just going to show you how easy it is for the configuration. Here's a drop-down menu. You just basically choose the database that you're using. You click on Enable Query Caching. You choose the cache, the storage of choice that you want to use, whether it be Redis, Hazelcast. If it's in Amazon, Elasticache, it's automatically going to detect that in a drop-down menu, and you just choose what you want. And then you put in the JDBC URL. So remember, it goes application, Heimdall data, and then your vendor JDBC driver, which could be MySQL, Postgres, or whatever backend database. And that's it. I'm open to any questions that you may have about our solution. There's a free download that's available on our website. I welcome you to try it out. It's a 5-minute install, and I think you'll really find benefit if you have a SQL database. Brett?
No one's typed any questions yet in the chat. We can give it a minute and see if anybody thinks of anything.
Okay.
Anybody? Anybody have any questions for Roland?
You guys are awfully quiet today.
They are a quiet bunch today. What was that URL for people who wanted to try it, Roland? I'll paste it here in the chat for anyone.
Oh, sure. Let me get there really fast. Right here. Let me take a look. It's literally if you're using Linux, it's literally a 1-line install right here. We have a Docker file. We're on the marketplace. We support Windows or any vendor-neutral operating system.
I'll ask a question. You mentioned Docker. Is this something that you would bake into your Docker container, or would you probably deploy this as its own container and just point your application server to it?
Up to you. It's a Docker file. I had explained that we can deploy it in a distributed fashion where it's in the Docker container, which is the most performant. You get the best benefit that way in a distributed fashion. But if you want a centralized mode for which all the applications talk to a centralized Heimdall data Docker container, you can do it that way as well. It's cheaper to do that way, but it's not as high performing. Either way you want it. Okay.
Cool.
And we're in the marketplace as well. It's a free download in the marketplace. So you can send your email to us, and we'll be happy to provide some free consulting to help you get online and see where we can optimize your application via SQL.
Excellent. All right, last chance for anyone if you have any questions. If not, we can probably be done then. Roland, if you can send potentially the slides you used, we'll post those along with the recording for anyone who comes along afterwards. There's a lot of people who work during the day, so they'll catch this recording later on.
Sure, I'll do that.
Okay, Javier, I think you can probably stop the recording. I don't see any other questions, so thanks a lot.